Hey guys, so today we're going to talk about equilibrium. Equilibrium is represented by the constant KEQ, and it tells us whether we are going to favor the products or the reactants. So when you have your KEQ equal to 1, you're not going to favor either of the products or the reactants, because if it equals 1, then when you think about the equation that KEQ equals, because KEQ equals the concentration of the products with the coefficients divided by the concentration of the reactants, also with the coefficients. So if you think about it, if it's going to equal 1, then they have to be about the same, so they're going to equal each other. If you have KEQ as less than 1, or 10 to the negative 5th power and smaller, you are going to favor the reactants, because when you think about it in the equation, if the the reactants have to be bigger to make it that negative, and the products isn't going to be that, it's not going to be really big, because the reactants is going to have to be so much greater than that. And the same concept with the, if KEQ is greater than 1, or 10 to the 5th and bigger, the products are going to have to be so much bigger than the reactants, because the reactants aren't really going to matter, because this number is going to be so big. So two things are not included in equilibrium, and those are solids and liquids. They are not included in equilibrium, so if they are in your equation, or if they're one of your products or reactants, you cannot include them in the equation, because then it will totally mess up your whole equilibrium. Okay, so since we know that KEQ equals the concentration of the products with the coefficients at the top, and the concentration divided by the concentration of reactants with the coefficients at the top, we can look at the equation for HCl gas plus O2 gas yields 2 H2O gas plus 2 Cl2 gas. So if we do that, and we do the concentration of the products and divided by the concentration of the reactants, we know that KEQ equals the concentration of H2O squared, because there's a 2 in the coefficient in front, times the concentration of Cl2 squared, because of the the coefficient in the front, all divided by the concentration of HCl to the 4th power times the concentration of O2. Alright, so our next equation is CaCl2 solid yields Ca with a 2 plus charge aqueous plus 2Cl with a negative charge aqueous. So we know that we can't include solids, so we're going to mark that off, because that can't be included. So we know that KEQ equals the products over the reactants. So in this equation, we don't have any reactants. So we only have the products, which is going to make us have it equal to just the concentration of Ca with a 2 plus charge, and times the concentration of Cl negative charge squared. For the equation, MgO solid plus CO2 gas yields MgCO3 in a solid you know that since we can't include solids, that's going to take this out of the equation and this out of the equation. So all that's left is going to be the CO2 in gas form. So we have products over reactants. So we have no products. So what do we do? So to substitute when we don't have something on one side, we just put a 1. So since we have no products, we're going to put a 1 on top. And then on the bottom, we're going to just have the concentration of CO2. And that's all. Alright, so now we're going to talk how equilibrium shifts when you change certain factors. Equilibrium is going to shift when you add or remove any of the any products or reactants, when you change the temperature, and when you change the pressure. So, say we're going to add N2O4 to the equation that you see here at the top. So if we're going to add N2O4, that is going to change the concentration and make this side of the equation less concentrated. So it's going to shift the equilibrium to the right side of the equation because you're going to go to the opposite side. So that's going to make the concentration of N2O4 is going to go down, but the concentration of NO2 is going to go up. Say if you're going to remove N2O4, that's going to make this side, the left side of the equation, more concentrated. So then you're going to move, the equilibrium is going to shift to the left. So then the concentration of N2O4 is going to go up, but the concentration of NO2 is going to go down because it has to balance. Okay, so then when you change the temperature is on the right side of this equation. So if you're going to add heat, it is going to shift to the colder side to try to balance it out. So since the heat is on the right side, it is going to shift to the left. So then the concentration of N2O4 is going to go up, but the concentration of NO2 is going to go down. Because you always want to go, when you're adding heat, you go to the colder side. But when you're removing heat, you go to the warmer side. Now pressure. Pressure deals with the how many molecules you have. And so on this side of the equation we have 1, but on the other side we have 2. So it's when you're taking away pressure, you go to the side with more molecules. So we're going to shift to the right side of the equation. So the concentration of N2O4 is going to go down, and the concentration of NO2 is going to go up. But if you add pressure, you go to the side with less molecules, so it would be the opposite. Alright, let's try some examples. So, the equilibrium constant for the equation CO gas plus H2O gas yields CO2 gas plus H2 gas is 302 at 600 Kelvin. What is the value of the equilibrium constant for the reverse reaction at the same temperature? So basically, we know that KQ equals 302, and 302 equals the concentration of CO2 times the concentration of H2 divided by the concentration of CO times the concentration of H2O. So, to figure this out, we kind of just do some basic logic. So we know that KEQ of the reverse, and I'm just going to put R instead of writing out reverse, So we know that that is equal to, just flip them. So concentration of CO times the concentration of H2O divided by the concentration of CO2 times the concentration of H2 is, so then to figure that out, since we flipped this part of the equation, we just flipped the answer too, so then we just have 1 over 302, because 302 is understood to be over 1, so we just flip it to get our answer. Alright, next problem. At the equilibrium point in the decomposition of phosphorus pentachloride to chlorine and phosphorus trichloride, the following concentrations are obtained. 0.010 moles per liter PCl5, 0.15 moles per liter PCO3, and 0.37 moles per liter Cl2. Determine the KEQ for the reaction. So we know that since it's decomposition, we just could write the equation. PCl5 yields Cl2 plus PCl3. And we also know the concentrations. The concentration of PCl5, the concentration of PCl3, and the concentration of Cl2. So then we also can figure out that KEQ equals the concentration of PCl3 times the concentration of Cl2 divided by the concentration of PCl5, because that's what KEQ equals. The concentration of products over the concentration of reactants. So then we just plug in the numbers, 0.15 times 0.37 and 0.010, and then we just plug that into our calculator, and we find out that KEQ equals 5.55. But since the most sig figs that we have are 2, it's 0.56.